Good afternoon, Robert Scribbler. It is July 17th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now for this segment, I am going to talk to you about a historic wildfire outbreak that is now ongoing in Sweden. In summary, thousands of people have been evacuated due to 80 wildfires burning throughout the country, and this is an unprecedented event that is resulting in Sweden calling for local volunteers and fellow European nations for aid in what is probably one of the largest outbreaks of wildfires in Sweden's history. Now, what I'm going to do is provide for you an overall assessment of the weather and climate change related factors that appear to have contributed to this wildfire outbreak. Now, first, I just want to look at the satellite picture with you. This is a satellite picture of Sweden and the Scandinavian countries and the Baltic Sea region, with the Barents Sea here to the north and the North Atlantic here to the west. And as you can see in this zoomed out satellite picture, you can see some wildfires burning, clearly visible even in the long-range satellite shot, as well as a large smoke plume that's about 400 miles long extending off to the north. Now if you notice the cloud formations, you'll notice a large bowing, and that's indicative of a high-pressure ridge that has settled in over the Scandinavian countries for a number of days now, lending extreme heat to the region. I'm going to go ahead and zoom in so you can get a better look at these fires. Some of them are quite intense, and this visual representation on the satellite shot is quite stunning, where you can see these large smoke plumes and very large burn scars from a sequence of what appear to be three fire complexes. Now, not all fires show clearly up in the satellite shot, but according to Swedish media, there are now more than 80 fires burning across the country. One of the primary factors in the present Swedish wildfire outbreak is much warmer than normal temperatures, and this is a GFS model showing temperature anomalies, so departures from normal on the cool or hot side, the 1979 to 2000 baseline, which just for context is also a warmer than normal baseline. So if you were to compare it, say for example, with normal 19th century readings, much of this map would be showing up in yellow, orange, or red. But for these purposes, against this baseline, temperatures in Sweden are ranging between 10 and in some cases 15 to 20 degrees Celsius above normal. And this is translating at the surface to very warm temperatures during the peak heating of the day. These are Celsius readings, so a 30 degrees Celsius reading, for example, is roughly comparable to 85 degrees Fahrenheit. This 32 degree reading over here across the Baltic Sea is very close to the 90 degree range. So these are Scandinavian countries just on the edge of the Arctic Circle. Some cases during summertime, Sweden even experiences snow. And there are permafrost regions in Scandinavia. So just to give you an idea that this is very far outside of the context for typical Scandinavian climate. Now, these warm temperatures are one contributor to fire hazard, is a primary contributor to fire hazard, and it's one of the reasons why human-caused climate change is increasing fire risks across the globe. But another reason that human-caused climate change is contributing to wildfire risks is that rising temperatures also increase evaporation rates from lands and soils and forests, and this results in increasing drought intensity and increasing prevalence of what is known as flash drought. Now, flash drought occurs when when it gets rather hot, typically, and lands dry out very fast. And this is a new phenomenon that's related to human-caused climate change. Now, to be clear, Europe has experienced warmer than normal conditions at least since May, and drier than normal conditions through the same period. And so now we are seeing record levels of drought in many cases, and this is a global drought monitor graphic, and where you see the red is where soil moisture levels are much lower than normal. Areas in blue are higher than normal. So as you can see, there's severe drought over Sweden, over much of Sweden, particularly over parts of southern Sweden. And in addition, much of Europe right now is facing drought, which among other things is leading to serious stress to farmers, but is also a primary contributor to the present wildfire situation. And as we said before, this is also a climate change related signal. Now, moving more to upper level weather patterns, we see a strong upper level high pressure ridge in the jet stream, and kind of a split here in the jet stream where it extends off to the north well into the Barents Sea. And this upper level high is enhancing the much warmer than normal temperatures here, translating down to the surface. In and of itself, upper level ridges are not necessarily climate change related features. However, we have seen significant reductions in sea ice north of Svalbard and in the Barents Sea, and reductions in sea ice in some models have shown a tendency for jet stream to move more to the north, which can result in more prevalent and stronger high pressure ridges, in addition to bringing in warmer air from the south. And so those are factors that can influence high pressure ridges that are related to climate change. Now, moving down back to the surface, I'd also like to look at sea surface temperatures and temperature anomalies with you. I'm going to zoom out a bit, give you an idea of what's going on here. Now, if you look at the UK and east of France and on into, west of France and on into a region east of Iceland and west of Scandinavia, most sea surface temperatures in this region are much above normal. That's a 4 degrees Celsius above normal reading, and in the range of about 1 to 4 degrees Celsius. Now, if you get into the Baltic Sea, sea surface temperatures are extraordinarily warm, in the range of 5 to, in some cases, close to 6 degrees Celsius above normal, and that's really extreme. And in the southern Barents Sea and through hotspots near Svalbard, parts of the Barents Sea are also very warm. Now, very warm sea surfaces are a signature, have a climate change signature signal, and also influence weather patterns in surrounding regions and can enhance both drought and extreme rainfall events when they do occur, depending on the nature of the weather systems that fall into place surrounding these warmer than normal ocean temperatures. And in this case, it's tended to enhance strong ridge patterns and warmer than normal temperatures, which have tended to provoke drought type influences. Now, to sum up, Sweden is again battling a historic wildfire outbreak, and though there are other signals related to this outbreak, climate change signals are figuring rather large. And just to sum up with a little bit of a picture here, I want to show you this ice edge that is here to the north of Svalbard, which is among the greatest retreat that we've seen in sea ice in this particular region in the record. So thank you for joining me, and if you're living in Sweden, hope and solidarity to you from America, and we hope you get through this crisis soon. Thank you.